Welcome to our last video for Chapter 5. We talk about density. This is the strangest picture. Take a close look at it. If you put Pepsi, pure, like not diet, just Pepsi, you can do this with Coke too, in water, it sinks. But look at the diet. It floats. It's all about density. Density is a ratio of mass to volume. Seems easy enough, right? Well, you can use this as your formula, density equals mass divided by volume, or you could just follow your units and make sure your units are where they belong. See, mass has a unit of what? Well, if you guessed grams, you're spot on, and the symbol we use for grams is G. Volume has a unit, in this case, not liters, but densities measured in milliliters. And the symbol's ml. So I could rewrite the density ratio above not as density equals mass over volume, but as density equals grams per milliliter. Density can be thought of as a ratio, just like I said, of grams to milliliters. And you can think about this visually by looking at particles in a box. So in the first box, well, we got to get the volume of the box. Well, the box happens to be 1 by 1 by 1 centimeter. So we can get the volume of the box easy peasy, right? Do you remember the volume? How to get the volume of a box? Well, if you guess length times width times height, you're spot on. So it's 1 by 1 by 1 centimeter, which gives us 1 centimeter cubed. Yay, we have the volume. Oh, but the units don't match. I have a centimeter cubed, and I'm supposed to have milliliters. Well, good news. The easiest conversion ever is right there. 1 milliliter is equal to 1 centimeter cubed. See? 1 milliliter, 1 centimeter cubed. It is the easiest conversion ever. So if I have 1 milliliter cubed, I can easily convert that to 1 centimeter cubed. See, because if I have 1 milliliter right here, up here, and I say I had 42 milliliters. If I had 42 milliliters, I can easily convert that to 42 centimeters cubed. So 1 centimeter cubed is the same thing as 1 milliliter. So now that we've got the volume, let's take a look at the mass. Well, if we have each ball representing 1 gram, then how many grams do we have? 8 grams is correct. So we're going to take that 8 grams and put it there. I'm ready to now calculate the density, which is 8 grams per milliliter. Let's take a look at this box. Do you think the density is going to be more or less? If you said more, you're absolutely right. Clearly, they're packed in there a lot more tightly. The density is greater in this case because the mass is greater. Whenever this numerator up here, whenever this numerator is bigger, sorry, I was going to say greatly bigger, but whenever it's bigger than the denominator, the mass is going to be greater than 1. And if the numerator is smaller than the denominator, then we're going to have less than 1. Because density is a ratio of how much crap you have packed into a certain space. The density of water is one of the important things you need to learn to speak chemistry, and I know it continues to go on and on. To form the basic skills to be fluent in chemistry as we move forward, there is a lot of stuff that you have to know. I get that. Water, and it's like most fluids, it depends on temperature. We're going to use the value of 1 gram per milliliter as our density of water. However, you should know that that's the density of water at room temperature, which is about 20 degrees Celsius. Water's strange in this part of the curve. Water is actually most dense, and this graph doesn't show it as well as it should, but at 4 degrees Celsius. And as water becomes even colder, its density goes down. No other substance does that. Every other substance, as it would get colder, all those molecules packed into that space would just get closer and closer and closer together, and water doesn't do that. Water's density at -20 is much less than what it is at room temperature or even at 4 degrees. Why would that be? And what effects does that have? One of the things that you can see about this is ice cubes float in your glass of water. Well, they float in your glass of water because they happen to be less dense than liquid water. Any other substance, if I took it solid and put it in its liquid, it would sink. Not with water. Nope. Ice fishermen are real happy about this, as are people who like to ice skate on actual lakes. What would happen if ice behaved like every other solid and sank in its liquid? What would happen to our lakes? From a chemistrian point of view, this is why ice floats. This first picture represents solid ice. And as you can see from the solid, there are not solid, don't have my pen today, I'm just kind of using the PowerPoint. The solid, the atoms are not packed in as tightly as they are in the liquid. So if you think about density as being a ratio of mass to volume, or the amount of crap packed in a certain amount of space, the solid has much less packed in to the same amount of space. Therefore, it is less dense. Can a bowling ball float? What do you think? Take a bowling ball, put it in water. Can it float? Well, it depends on its mass. This first bowling ball has a mass of 8 pounds. The 8-pound ball floats. Because remember, density is a ratio of, that's right, mass over volume. In this case, the density of this bowling ball, the mass is less than, so the numerator is smaller than the denominator, which gives us a number less than 1. And since water has a density of 1, the ball floats. A 14-pound ball, the density is equal to mass over volume. And with the 14-pound ball, the mass is greater than the volume, which means the result is greater than 1. And the ball sinks. So, why does the diet float and the regular can sink? And we're done with the chapter. The very next chapter we're going to tackle is chapter 6, where we talk about the mole. Have a great night.